Afternoon, or sorry, good morning. How's everyone doing? Hanging in there? So my name is Andrew Nelson. Many of you guys already know me, being here for several years. Consultant in North America, with Red Hat over 8 years. Been in the Zabbix community for more than 15 years or so. It's been quite a long time, actually. Also did the Ruby API library, and also have a couple of part-time hobbies, whenever time available for me. So let's get straight into it. So what is Performance Copilot? That's what I'm here to talk about today. Performance Copilot is a program originally written by SGI back in the late 80s, early 90s. And it was essentially a way to pull performance metrics out of your SGI and systems. Fast forward a few years, it had several iterations with many other companies after SGI. Now Red Hat is one of the groups that's involved with keeping the upstream source code of this maintained and so forth. It's a very straightforward process. Many of you guys in Zabbix will already, as we see it later on, look very, very familiar. Basically, it's a key value kind of system, very much like how keys are done in Zabbix items. So what's the layout of Performance Copilot? So there's a couple of major components to it and so forth. The major ones, is the Performance Copilot collector daemon, the PMCD. So the PMCD is essentially what everything connects into and collects the data. That's essentially your daemon that runs. You'll then have PMDAs, or the domain agents that will connect into that. And these will be ones that will pull information on, let's say, libvirt, KVM, Docker, or various other components. So if you wish to have another component to add into, for PCP to monitor, you would basically have it connect right into there. And then there's the performance metrics namespace, which is essentially where a lot of the utilities are. This will be PMinfo, PMchart, PMval, PMRPT, and a few others. So what are some of the PMDAs that are out there? As you can see, it's quite a decent variety that are in there. But it's also really exciting as you start to dive deeper into Performance Copilot, that some of the new features that are available, like Satellite 6.4, is just come out recently, and that one also has a PCP agent to it, so you can start to look in deeper and see how various components within Foreman and whatnot are performing. It's especially useful for looking deeper into your satellite instance to try and isolate out some performance improvements or understand how it's working a little deeper underneath it all. Also, we have PMDAs for Gluster, and then also for 389 Directory Server, which 389 is the core component to Red Hat Directory Server, and 389 is also the core component of Red Hat IDM, or Identity Management Software. So using Performance Copilot, you can gain insights into the performance of these various utilities, and so forth. So what does PCP look like, from the command line? So we basically have, we're using the PM probe program here, and basically it will probe the namespace and pull back some information. So what are we looking at here? First one, we're going to see we have an ability. We're looking at, let's see, what's underneath libvirt, domain stats, and network. So here's all the various ones we've got here. The 3 that's next to this is telling me I have 3 items available underneath there. We'll see some of those later on, how to pull those. So those are kind of just a high-level view of what you can pull directly from libvirt using PCP. So let's go a little closer. Let's have a look at PMinfo. PMinfo is a very useful utility that will pull a lot of the information that you want to do. So basically, we're going to PMinfo. We're looking at T will tell us to pull back the help information about it. F will pull back the actual value that we're looking for. We're going to once again look for libvirt, domain stats, net, all transmit packets. So we're coming back. It's a data type of a 64-bit unsigned integer. We have, it's a counter. There's no virtual machine nix is the help tag. And since there was 3 items that it could pull back, there's the 3 items we can get. Now it's kind of interesting because this is the UUID for the virtual machine. So it's kind of an interesting one when you're looking through there. So what does the PCP, the GUI, look like? This is the PMchart utility. PMchart's another very useful utility as well, because it can allow you to very quickly look at some data and so forth. So we do that. We can pull it up, Let's have a look at something from the kernel. Let's have a look at entropy. What's our current available and what's our pool size of entropy? All right, so let's go back and let's look at that. Hey, something happened to our entropy here. Now, what's interesting is by default, a lot of this stuff will poll at a 1-second interval. So and I'll tie this here in a second. A lot of the stuff that you'll see within PCP is a very granular data set. 1-second intervals, is not uncommon, and so forth. But this is the same source that we can have our Zabbix agent go from as well. So our Zabbix agent may be on maybe a 1-minute timeline, 2-minute, whatever. But here we're looking deeper at specific entries, but we're using a single source of data between Zabbix and what our host is looking at, which is most important. In a situation here, it's just, I basically was catting out dev random. And by catting out dev random to dev null, well, I'm going to ruin my entropy because I've got nothing left. So it's kind of interesting to see that and see how the pool looks and everything else. Here's another example. So let's look a little deeper. This is basically having a look at some NFS stats. A lot of us have had to do some performance tuning and analysis of our NFS. So at the top, we've got our read writes that are coming across. This is from the client looking outward. So our read writes coming across, so not really much there. Network bytes in and out, we're starting to get a little bit more here. TCP sockets, we can also look at how our TCP sockets are doing in relation to everything else because everything's on one timeline. Let's also look at go as TCP socket memory, what our total is there. So we can kind of see that, as things happen, the time wait starts to come up as some of our sockets start to close and so forth. So it's kind of to be expected. Many times when I've done this in the past with the Zabbix NFS, I've looked at it in less than a 1 second, or sorry, more than a 1 second granularity, closer to 15 seconds or something like that. But like I said, this is a very light way of looking at it for a very short granular piece of information. And we also look at some various other NFS operations that are occurring so we can kind of see when those happen, IO stats and so forth. So let's tie this all together. Let's bring this into Zabbix. So how do we do that? It's actually very, very straightforward. It was surprisingly straightforward to me the first times I started playing with this. So we basically got to install the proper RPMs. The Zabbix PCP, or sorry, the PCP export Zabbix agent is available in the RHEL 7 optional repository. So that one does come from Red Hat. PCP is in the standard Red Hat repo, if I remember right, the standard RHEL repo. So we basically install the RPMs. We start the monitoring daemon, the PMCD. Then we basically go into our Zabbix agent config file. We add the loadable module to the config file. And we restart the agent. Huzzah, we've got a data point. One thing that's worth noting that all stuff that comes from PCP, from the loadable module, starts under the PCP namespace. So, if I were to be on using PCP, PMinfo to pull the information, I'd look PMinfo kernel all sysfork. But since I'm doing it in Zabbix, it's pcp.kernel.all.sysfork. So once again, let's go back to the libvirt one that I showed you a few seconds ago. So here's another one that we're looking at. We want to pull this into Zabbix. We want Zabbix to look at the network information of my virtual machine. But we want to do it from the hypervisor. There's many things I can do. I can even look at the virtual NICs that the hypervisor spins up, but then the virtual NICs may change as the guest comes down or spins up, so forth. This way I can tie it to always the same interface. So we pull it in. Once again, I did talk about the UUID problem that we have here. So we've got to basically go that first. But the way to do that is simply you can ask Versh to tell you what the UUID list is. So here's two ways of doing it. Or we can even actually look through PMinfo, because there's another one that will show us where the UUID maps kind of to the name and so forth. So we take that UUID and we basically then bring it into Zabbix. We create our item. As you guys can see, it's a very straightforward one that we've done here. I've just happened to create a macro in this situation that I've stored. That way I can do multiple items for the guests that I'm looking at here. And I'm just looking at the bytes per second for the interface. Here's what it looks like in the end. The very top one is this is my Zabbix VM that I'm looking at here from the hypervisor. So the Zabbix VM, this is what it's presenting as itself here. And then this is what the hypervisor is saying the Zabbix machine is doing in terms of network. You can see a very strong correlation between the information. You will notice that everything is off by a factor of 8, bits versus bytes. So it's kind of worth noting there. May need to fiddle a little bit with that. But it's kind of useful because now we can look at what the hypervisor is saying, the guest is doing on the network, and we can also have this track that guest, guest as it moves throughout the hypervisor, spin up, spin down, change the network, and so forth. So derived checks is kind of another really powerful feature within PCP. So normally we would call that calculated items that we might do, but we can basically take multiple things within an instance. We can maybe take 2 different networks, add them together, create another aggregated one. We could maybe take several pieces of information, aggregate them together, and then present that as an aggregated item. The nice thing about doing this is it's doing it kind of offloading from within Zabbix, allowing it to be done at the source of the information before it's imported into Zabbix, and allowing it to be easier to be ingested. What's interesting is there are some of these that are already done this way. So if you look through, you'll find that almost all of these, actually all of these keys are done using derived items natively within PCP. So if you start using PCP for pulling this stuff, you're already using derived items out of the box. Now, one of the ones that is interesting is you can set this in the main directory for PCP use, or you can set ones that are Zabbix specific using its own config file and so forth. But one of the ones I also noted here was the rate one is kind of akin to Zabbix's change over time. So essentially we're looking at what's the average queue length. It's basically read, write active, and write actives over a period of time. What's the total based on the time you get. Now what's interesting about the rate though is that's based upon when you query it. So PCP kind of keeps track of when you query it. So if you query it at time 0, well, that's the start of your delta. You query it 10 seconds later, well, that's the timeline. Let's figure it out, and let's give you the answer. If you query it 1 second later, well, that's your timeline. Let's figure it out. Let's give you the answer. So you don't have to figure out your timeline up front, which is kind of nice. So here's a really awesome one that's capable. So extended Berkeley packet filters. Basically, many of you guys have probably already used this when you use TCP dump. TCP dump basically uses Berkeley packet filters. And this is kind of an enhancement of that, except it's looking into the Linux kernel. This allows you to do traces in the Linux kernel and kind of set trace points and so forth, and begin to set counters for what things happen and so forth. One can look at it as kind of taking dtrace and system tap kind of to the next step. You don't necessarily have to have quite the same level as kernel source code. BCC is the Berkeley compiler collection. It's essentially a set of tools that makes easier to build these eBPF rules to look at things. So one of the really awesome ones is, when you install it in, there's one of the items was run queue latency. So essentially, let's look at our run queue on the host. Let's get a histogram of the latency of these ones. So we have, within the timeline that we've looked here, we've had 622 that take between 0 and 1. I believe this is milliseconds. And then we've had 500 or 5,600 processes between 2 and 3 milliseconds, and so forth. And this keeps growing and growing. So we then look at in there. So we pulled all that in. Yep. Let's add it all into Zabbix. So as you can see now, I've created this one. I've had to create it for each item, but now I've basically got my whole set of run queue latencies and everything in there. And now I can graph the whole thing. So this basically kind of shows you how the run queue, the latency of it, has been over a period of time. As you can see, it was pretty idle, and then at some point something happened here that basically caused the run queue to start to do a lot of processing. So it's kind of useful for you to look at over a period of time how your CPU is doing. Also by setting the graph colors to be very similar within groupings, but changing enough, you can kind of look at it and go, okay, which band of timing am I seeing? Am I starting to see a growth in a time band that's a larger time band? Because then you might start to see that, and then start to begin to look at things like Little's Law and determine where you want to do your performance analysis. So overall, it's a pretty straightforward way to do that one. So the main resources are available through the PCP main website. There's a couple of other really awesome features in PCP that didn't touch on too much in here, and one of the neatest ones that I've found is something called memory mapped values, or MMVs. Basically, it's something you would attach into your software, and it creates a namespace similar. It works in a similar manner to how Java Beans work. You basically will update a value in your memory map value. You then can let PCP query that value. So let's say you have something in your software, queue size, or something cache size within whatever software you've got. And you can basically just keep that counter going. And then if no one is looking at the counter, well, it's not a problem. But now you've got a performance issue you wish to look at. You can now point PCP at this, or you can have Zabbix point at that through PCP and monitor that over a period of time, and then alert someone, hey, our software's starting to show some early signs of degradation. Maybe we might want to do something in there. So that's a pretty neat thing. There's also utilities then for Java. There's a utility called Parfait that does the very same thing as well. And then there's other libraries out there as well. So, but yeah, come have a look. We've also got a list of other resources and white papers that have been done that talk about this one as well. So, thank you.
Thank you. Thank you, Andrew. Please, questions from the application.
All right. Thank you, Andrew. I've got a few questions from the community. First one is from Dmitry Zat. Do you need a root permissions for PCP to collect metrics?
So the agent, I believe, runs as root. However, the users who connect to it do not need to have root. So I can basically connect to it as my own user when I'm doing PM info, or PM report, PM chart, and so forth. One thing it is also worth noting is you can set up the PMDAs to respond to external hosts. So I can run PM chart on my local desktop, and I can connect to a PMDA on a remote host. Normally, there's no authentication kind of by default in there other than firewalling and so forth, but within the PMDA you can set some authentication rules and so forth, so you can actually lock that down from an authentication perspective, or just completely firewall it off. But to get back to the main question, I believe the domain agent does run as root. There are SELinux constraints around that one. So you may run into some of those, but yes, the domain will run as root, but you can access it as a normal user.
All right, thank you. Another one came from Daniel. Do you run a PCP agent in a Docker container along with some microservice and got it monitored by Zabbix this way?
So yes, so that's actually a good question. One of the domain agents, one of the PMDAs that is available is for Docker. And so you can run that on your Docker host and then pull specific Docker information. I was looking at it the other night, and it looks like the two basic ones out of the box is CPU per container and network per container. So you can kind of look at the CPU and network load, and it's pulled back by a UUID. So using a very similar process to what I talked about here with libvirt, you would use the same Docker process to pull that information through, allowing you to use PCP to monitor Docker and then store it all in Zabbix, and use the whole Zabbix framework there for your monitoring and alerting.
Thank you.
Yeah, more questions, please. We have.
All right. Another one. Does it work with SELinux enabled on Red Hat 7.x?
Yes. So all Red Hat products essentially are tested and QA'd with SELinux enabled. That is a best practice for us. That we believe that everyone should be running with SELinux in enforcing mode whenever possible. However, there are some situations that you may run into. I've already run into this myself. That some of the PMDAs will try and access some information that it's constrained from through SELinux. So in those scenarios, yes, it would be recommended to open a bug report, a support ticket for those, and then they can be addressed as quickly as possible. But for the bulk of them, SELinux should be in enforcing mode and should work without any issue.
Right, thank you. And pretty much last one?
Yeah, Yeah.
All right. Last question is, you said that this can be found in Red Hat Enterprise Linux optional repository, but what about CentOS? Is this available to CentOS users?
So CentOS basically takes Red Hat source code and it takes out some of the branding and does a couple of minor adjustments to it and then recompiles. So I would fully expect this to be in CentOS. I would actually be very surprised if it was not. However, I do not know which repository specifically it will be found in. It'll probably be in probably the optional extras repos, off the top of my head. But I would fully expect this one also to be found in CentOS just because CentOS recompiles Red Hat, source RPMs.
All right, thank you. I think that's it for the questions from the app.
Yeah, maybe some questions from the audience. Yes, please.
Yeah, thank you.
Yes.
Hello,
Yes.
Thank you for your presentation. And my question related to NFS. On one of the slides, I found that there is some NFS-related metrics. And my question is it possible to monitor availability and performance of NFS mount point inside Red Hat, for example, using PCP?
So,
Especially availability.
so let's step back for a second. So you want to know, monitor whether the mount point is active?
Is it available?
So yeah.
Information from this mount point or not?
So that would be, yeah, so that would, I would not expect that to be something from PCP, from the availability. That would probably be something along the lines of a script to say, hey, is it mounted and so forth. But if it is mounted and you're in an I/O block state because it's maybe a hard mount, for instance, is probably the situation you might be thinking of. For that one, I think you would probably want to start looking at probably some of the I/O operations around NFS. I don't know yet on that one, but I would start to think maybe that you might start to see some of the I/O operations. Those might increment higher than you would normally expect. So yes, it would be something like this you'd want to maybe play with and then learn deeper and so forth. But it may, the answer may be in here. I just don't know exactly where it might be.
Hello?
Yes.
Is it possible to integrate it with Kubernetes or OpenShift to get metrics into Zabbix?
So it's kind of interesting. There's a set of OpenShift modules that are out there for Zabbix monitoring. Red Hat actually uses Zabbix to monitor our public OpenShift instance. I was looking through a lot of this stuff, and I didn't necessarily see PMDAs that I observed for OpenShift. Now, I could have also just easily missed it when I was reading through a lot of them because there's a very large list of PMDAs available. But you may be able to leverage some of the components around the Docker ones. I don't know if there's a Kubernetes PMDA, but you may be able to leverage some of those on top of your OpenShift nodes and so forth. But there's also the OpenShift modules that we have used for our monitoring of OpenShift with Zabbix as well.
Thank you.
Yes.
Yes,
Yeah.
please.
Yeah. A question is, can I request all information by PCP to try to use a master item, independent item, avoid to make a lot of requests to Zabbix agent?
So say this, start that one over again.
I wanted to request all information, a lot of information at the same time in this, by PCP. To use the master item and dependent item, avoid to make a lot of requests to Zabbix agent.
So you're talking about trying to limit the number of requests to the Zabbix agent?
Yeah, because with the master item, I can request a lot of information at the same time, and after that, separate the values.
Yes, you're referring to yes, dependent items. So yes, you could do that out of the box. It's not necessarily there because the loadable module, the exporter as it's called, will export the data straight into Zabbix. So it becomes a one-to-one item relationship. So one item, one key, so forth. However, if you did want to do something along those lines, there is a JSON exporter that PCP does support. So you can do a JSON exporter to your JSON dump, and then somehow pull that into Zabbix, and now within Zabbix do your dependent items to extract the data out. So there is that capability. You can also use a similar method to that where you might take SAR and collect D data on a host and then try and export it out and then pull it into Zabbix and so forth that way. Because those are also utilities that come within Red Hat hosts, especially a lot of the SAR data that a lot of times we'll have to use to try and figure out what's going on here in the system. So.
Thank you, Andrew. Last question, yes, from the audience, please. Just a second.
Okay, Andrew, thank you. PCP looks very powerful. So what's about another Linux distribution like Debian or Ubuntu? Does PCP agent exist for these distributions?
Yes, so PCP is open source software. So we believe in the open source community, as you know. On the PCP website, you will see other links to other information, and yes, there are, I believe, compiled versions for Debian. I think I was seeing that the other day. So I believe that every major Linux distribution will have a compiled agent of it, somewhere. I would be surprised if there isn't one. Maybe you might find, some of the stuff falling apart with some of the, the architectures around the edge, some of that. But I would fully expect to find, that in the various repositories for the various distributions that are out there.
Okay, thank you.
Thank you very much for your questions. Thank you very much, Andrew, for your presentation.
Thank you.